Welcome to the Cyclone 5 to Intel Agilex 5 FPGA Migration Guide. This online training will give a summary of some of the differences between the Cyclone 5 and Intel Agilex 5 devices. Here are the topics that I will go over in this training. I will briefly go over device footprint, power management, configuration, design resources, I/O, hard processor system, transceivers, PCIe, Ethernet, and project migration. With the product features and device performance enhancements, expect the device footprint between Intel Agilex 5 and Cyclone 5 devices to differ. Intel recommends recognizing the Intel Agilex 5 package and identifying the suitable part number to use in your design. Cyclone 5 device series offer only the standard ball grid design. Intel Agilex 5 devices offer variable pitch ball grid array and standard ball grid device package types. Most of the Intel Agilex 5 device packages use the VPBJ design, which you can identify through the package code starting with B and the conventional standard ball grid design package starting with M. The Cyclone 5 does not have the Smart VAD technology, but this option is available in Intel Agilex 5 devices D-Series and E-Series devices, with power option code -B. Devices operate at the optimum core voltage that meets the VAD power limit and requires device performance for various FPGA applications. The dynamic voltage supply is necessary for VCC and VCCP using the PM bus compliant voltage regulator. The Smart VAD feature compensates for process variation by narrowing the process distribution using voltage adaptation. The Smart VAD feature allows a power regulator to provide the Intel Agilex 5 E-Series devices with VCC and VCCP voltage levels that maintain the performance of the specific device speed grade. The fixed voltage option is available only in E-Series devices with option code -S or -X. Devices supply fixed voltage to VCC and VCCE. Cyclone 5 and Intel Agilex 5 have different power sequence recommendations. In the Power Rails Groups table, the Cyclone 5 device supports two power groups, where Group 1 must ramp up to a minimum of 80% of its full rail before Group 2 starts to ramp up. For Intel Agilex 5 device, all power rails in Group 1 must ramp up in any order to a minimum of 90% of its respective nominal voltage, before the power rails from Group 2A can start ramping up. The power rails within Group 2A can ramp up in any order after the last power rail in Group 1 ramps to the minimum threshold of 90% of its nominal voltage. All power rails in Group 2A must ramp up to a minimum threshold of 90% of its nominal value before the Group 2B power rails can start ramping up. The power rails within Group 2B can ramp up in any order after the last power rail in Group 2A ramps up to a minimum threshold of 90% of their full value. Cyclone 5 devices support the hot socketing feature, also known as hot plug-in or hot swap. This feature allows you to drive signals into the I/O pin before or during power up or power down without damaging the device. Intel Agilex 5 devices do not support the hot socketing feature. You must adhere to the design guidelines on I/O pin voltage and current limit for unpowered power-up and power-down device states. The following table provides an overview of the supported configuration schemes between Cyclone 5 and Intel Agilex 5 devices. In summary, Cyclone 5 device supports AS by 1 mode, but an Intel Agilex 5 device does not support it. Both devices support the AS by 4 mode. Intel Agilex 5 device supports the remote system upgrade and quad SPI flash access feature via AS by 4 interfaces of the Cyclone 5 device. Intel Agilex 5 device does not support the PS mode. You can migrate a Cyclone 5 device's FPP mode with the Intel Agilex 5 device's Avalon ST by 8x16 mode. Intel Agilex 5 device supports JTAG and configuration via protocol configurations of the Cyclone 5 device. Intel Agilex 5 device's CDP configuration time is shorter than Cyclone 5 because it supports PCIe 4.0 with by 1 to by 8 data lanes. To use quad SPI flash access and remote system upgrade feature in an Intel Agilex 5 device, replace the generic serial flash interface IP and remote update IP that a Cyclone 5 device uses with the mailbox client IP. Here are some feature comparisons between the Cyclone 5 and the Intel Agilex 5 devices. Both parts have error detection circuitry to detect soft errors. The Cyclone 5 part supports internal scrubbing for the E, GAX, SE, and SX devices with the SC suffix. External scrubbing is not supported on the Cyclone 5 parts. The Agilex 5 devices do support internal and external scrubbing. Error messages in the Cyclone 5 part can be retrieved with the message register unloader Intel FPGA IP with a JTAG instruction. For the Agilex 5 device, use the following tools: Fault Injection Debugger GUI Tool, Advanced SEU Detection IP, HPS SDM Mailbox Command. You can inject errors on the Cyclone 5 using one of the following methods: EDERROR Inject JTAG instruction with the Fault Injection Intel FPGA IP. Automate the testing process by creating a jam. HardisFID command on the command line interface. For the Agilex 5, you can inject errors using the following tools: Fault Injection Debugger GUI Tool, HardisFID command on the command line interface. Intel Agilex 5 devices support nearly all the same configuration file formats that the Cyclone 5 supports, with the exception that Agilex 5 supports raw binary files via JTAG, where Cyclone 5 does not, and Agilex 5 does not support the serial vector format. There are many more security features that are supported in the Intel Agilex 5 device than what was supported in Cyclone 5 devices. To start off, Agilex 5 devices have the Secure Device Manager module, which is a dedicated triple redundant processor that serves as the point of entry into the device for all JTAG and configuration commands. The Agilex 5 device bitstream can be encrypted as well as authenticated. When the bitstream is authenticated, this means that the bitstream comes from a trusted source. The method to decrypt the bitstream inside of the FPGA is through AES-CTR, which helps speed up the configuration process for the FPGA. Both volatile and non-volatile encryption keys can be stored in the FPGA and wrapped via the physically unclonable function, otherwise known as PUF. The PUF is like a fingerprint for the FPGA, so each FPGA has its own unique PUF that can be used with the encryption keys. And APS benefits from secure boot and boot code authentication in the Agilex 5 devices. Intel Agilex 5 device offers increased total RAM bits, ideal for larger memory arrays and more feature support such as force to zero and coherent read memory. In terms of Intel Quartus Prime IPs, you cannot directly migrate the on-chip memory IPs from Cyclone 5 fit Intel Agilex 5 devices. You must reinstantiate the on-chip memory IP. Every logic array block in the Agilex 5 device can be used as memory in the form of an MLAB. The basic architecture of the ALM still exists with the adaptive LUTs and 4 flip-flops, and the carry logic for fast arithmetic operations. In addition, the Agilex 5 carries on the innovative HyperFlex architecture of the previous Agilex families, which is in addition to the traditional ALMs with the LUTs and flip-flops. Part of the HyperFlex architecture includes flip-flops in the routing infrastructure. As with any IP that you create for your design, you will need to create any PLL IP core for the Agilex 5 device. Most of the PLL features from the Cyclone 5 devices are supported in the Agilex 5 devices, with the notable exception of fractional PLLs. Fractional PLLs are not supported in Agilex 5 devices. The clock network architecture in Intel Agilex 5 devices differ from Cyclone 5 device architecture. Intel Agilex 5 devices do not have regional clock and periphery clock networks. The Intel Quartus Prime Pro Edition software automatically determines the clock regions. Intel Agilex 5 devices use programmable clock tree synthesis for its core clocking function. Programmable clock tree synthesis uses dedicated clock tree routing and switching circuits. These dedicated circuits enable the Intel Quartus Prime Pro Edition software to create the clock trees your design requires. The clock network in Agilex 5 devices and all Intel FPGA HyperFlex devices consists of what is called a synthesizable clock tree network. The clock tree is generated during the play stage of the FIDR to accommodate the areas of the FPGA that contain design logic resources, so there is not the concept of a regional or global clock, as all clocks in an Agilex 5 device are considered global. Intel Agilex 5 devices offer an enhanced variable precision digital signal processing blocks with more supported modes. The DSP IPs do not support direct migration, so you must regenerate the IP if you want to migrate your design to an Intel Agilex 5 device. The Agilex 5 FPGAs support tensor mode and 16 and 32-bit floating point arithmetic functions, in addition to the various fixed point functions that were also supported by the Cyclone 5. What is pictured here is a DSP block configured as a 32-bit floating point multiply accumulate function. Tensor mode is dot products of 10-element vectors computation, which is useful as many AI applications. Intel Agilex 5 device supports different I/O types compared to the Cyclone 5 device. The following table lists the I/O interfaces that Cyclone 5 and Intel Agilex 5 devices support. Direct migration from Cyclone 5 to Intel Agilex 5 device is not supported due to differences in the I/O standard, I/O feature, I/O power supply, and bank architecture between Intel Agilex 5 and Cyclone 5 devices. Agilex 5 devices support a single HPS I/O voltage level and standard of 1.8 volts for LVC MOS. Configuration of the Agilex 5 devices happens through the SDM I/O, and there is also a single voltage of 1.8 volts that is used. The guidelines in this topic apply when switching your FPGA and board design from a Cyclone 5 device to Intel Agilex 5 device. Cyclone 5 device supports a wider VCCIO range, while Intel Agilex 5 HEIO bank targets a higher VCCIO supply range. For lower voltage range, refer to the HEIO bank section in the Intel Agilex 5 General Purpose I/O User Guide. Each HEIO block contains 2 HEIO banks. Each HEIO bank is further divided into 20 I/O pins per bank, and each HEIO block has its individual fabric-feeding I/O PLL. The table lists the I/O standard and features comparison between Cyclone 5 and Intel Agilex 5 devices. There are architectural differences between Cyclone 5 and Intel Agilex 5 devices. The above table shows that an Intel Agilex 5 device can support a higher data rate than Cyclone 5 and has a better advantage in terms of LVDS support channel when compared to a Cyclone 5 device. Intel Agilex 5 receiver can support additional modes, such as soft CDR and DPA FIFO, that Cyclone 5 devices do not support. As for VCCIO PO support, both devices are mutually different from each other. Intel Agilex 5 device only supports J-factor 4 and 8, and Cyclone 5 device supports J-factors from 4 to 10. In terms of supported I/O standards, Intel Agilex 5 device supports true differential signaling and SLVS 400 I/O standards. However, a Cyclone 5 device supports LVDS, SLVS, Mini LVDS, RSDS, emulated LVDS, emulated Mini LVDS, and emulated RSDS at the transmitter. Each Intel Agilex 5 HSIO bank contains its own PLL. The PLL drives all receiver and transmitter channels in the same bank. However, the bank PLL cannot drive receiver and transmitter channels in another HSIO bank. You must use the dedicated clock pins to drive the LVDS PLLs. For a Cyclone 5 device, each PLL drives all LVDS channels at I/O banks located at the same edge of the chip. There are differences between true differential signaling in Intel Agilex 5 device and other interfaces, such as LVDS, RSDS, and Mini LVDS, in terms of the VICM and VAD. For optimum performance, ensure that your design meets the VICM and VAD requirements of the receiver buffer in the Intel Agilex 5 device. The Intel Agilex 5 device introduces the sensor monitoring system that comprises on-chip voltage and temperature sensors. A Cyclone 5 device does not support this feature. You can use on-chip voltage and temperature sensors in the Intel Agilex 5 device to monitor external voltages and on-chip operation conditions, such as the internal power rail and on-chip junction temperature. The Intel Agilex 5 device voltage monitoring system uses a built-in 7-bit analog to digital converter. The ADC can sample up to 1 kilosamples per second. The ADC data output is stored in the SDM. You can read the voltage values in the SDM by using the Mailbox client Intel FPGA IP or the Mailbox client with Avalon ST Intel FPGA IP. The Intel Agilex 5 device temperature monitoring system allows you to measure the on-chip temperature using local temperature sensors or remote temperature sensing diodes. The Intel Agilex 5 device temperature monitoring system also supports the catastrophic trip signal, an optional signal you can assign to any unused SDM I/O pin. You can set the temperature threshold point for catastrophic trip signal from 95 degrees to 120 degrees Celsius in 1 degree increments through the device and pin options window of the Intel Quartus Prime Pro Edition software. The Intel Agilex 5 device offers an enhanced MIPI-D-PHY interface. In Cyclone 5 device, either the implementation to interface with D-PHY requires additional onboard passive circuitry, or you must go through Bridge IC to convert the MIPI-D-PHY signal into LVDS high speed and LVC MOS low power interface. An Intel Agilex 5 device supports native MIPI D5 version 2.5. It supports high-speed and low-power modes, and it allows direct interface with D5 compliance component without external components. D5 can perform up to 3.5 gigabits per second per lane. Each high-speed I/O bank supports up to a maximum of 7 interfaces. The supported data lanes per interface are 1, 2, 4, or 8, with 1 clock lane. To migrate your design, you must redesign the board circuitry and use the MIPI D5 IP from the Intel Partus Prime Pro Edition software. If you are implementing the camera or display interface, use the MIPI CSI2 IP or MIPI DSI2 IP integrated with MIPI D5. For more information, refer to the Intel Agilex 5 MIPI D5 IP User Guide. External memory interface migration between Cyclone 5 and Intel Agilex 5 E-Series devices is not possible because of the architectural differences between the two device families. Memory standard support in Cyclone 5 and Intel Agilex 5 devices are mutually different in each other. You must select memory protocol that Intel Agilex 5 devices support when planning to migrate from Cyclone 5 devices. You must also consider either migrating to Intel Agilex 5 E-Series devices that support only component memory type, or Intel Agilex 5 D-Series devices that support both dual inline memory modules, DIMMs, and component memory type. For controller interface, Cyclone 5 devices support Avalon Memory Mapped Interface Protocol, while Intel Agilex 5 devices support AXI protocol. The following table shows the supported memory standard for Cyclone 5 and Intel Agilex 5 devices. Hard processor system direct migration from Cyclone 5 SoC to Intel Agilex 5 SoC is not possible due to architectural differences. This list represents a summary of the notable differences between the Cyclone 5 SoC and the Intel Agilex 5 SoC devices. The Agilex 5 SoC has ARM Cortex-A76 and A55, a memory management unit, on-chip RAM that is 512 kilobytes as opposed to Cyclone 5's 64 kilobytes. There is a combination DLL-PHY, and the Quad SPI flash controller that would be used during FPGA configuration is found in the SDM. Also new in the HPS is the USB 3.1 Gen 1 controller and the I3C controller. The Agilex 5 SoC device has an SD-RAM controller that is not part of the HPS but resides in the FPGA. There are 2 booting and configuration options where you can configure the FPGA first, then boot the HPS, or boot the HPS first, then configure the FPGA, as opposed to the Cyclone 5 SoC, where you could also boot the HPS and configure the FPGA separately. Some peripherals that were supported in the Cyclone 5 SoC device that are not supported in the Agilex 5 SoC device are the Controller Area Network, FPGA Manager, and Scan Manager. Intel Agilex 5 devices significantly uplift the transceiver capability and performance from Cyclone 5 devices. Hence, you cannot directly migrate existing Cyclone 5 transceiver designs to Intel Agilex 5 devices. The following table outlines the key differences and their associated guidance that you must be aware of when upgrading to use Intel Agilex 5 GTS transceivers. The difference in the hardened block resources are that Agilex 5 devices do not offer 8B10B encoding, but rather 64B66B encoding. Also, Agilex 5 devices offer fire code and Reed-Solomon forward error correction, along with 1GB 25GB Ethernet hard IP. The recommendation if you need 8B10B encoding is to create your own user logic or instantiate Intel protocol IPs that include 8B10B, for example the triple speed Ethernet for Intel FPGA IP. Identify a fixed location for placing channels in bonded configuration up to by 8. No TXBLO sharing required across the channels. If multiple channels use the same rate, each channel is driven by its own TXPLO sharing the same reference clock source. Identify the external resistor value differences. The Cyclone 5 and Intel Agilex 5 physical medium attachment contain analog features to improve signal integrity. You can modify programmable values within Cyclone 5 receiver input buffers via a reconfiguration controller. Intel Agilex 5 device offers an advanced adaptive equalization circuit to compensate for transmission losses across wide applications. As Intel Agilex 5 PMA drive capability is significantly stronger than Cyclone 5 devices, reevaluate your board design for opportunities to remove any redriver or retimer previously connected to the Cyclone 5 device. For detailed information about the PMA architecture, Refer to the PMA Architecture chapter in the Intel Agilex 5 FPGA GTS Transceiver Architecture User Guide. The following table lists the key differences in TX and RX PMA features of Cyclone 5 and Intel Agilex 5 devices. Notice the differences come with the bits supported in the serializer and deserializer. On-chip terminations, the protocol support for electrical idle. The Cyclone 5 programmable CTLE versus the Intel Agilex 5 automatic CTLE, and the coupling modes. The physical coding sublayer architecture has evolved in the Intel Agilex 5 device to support a PMA interface FIFO, data scrambling, a gearbox to accommodate smaller data widths on the receiving end, and 64B66B encoding. Support has been dropped for 8B10B encoding and decoding, and the running disparity control feature. The recommendation is to implement in user logic if you need these dropped features. For more information, refer to the Intel Agilex 5 FPGA Transceiver Architecture chapter in the Intel Agilex 5 FPGAs and SoCs device overview. Clocking migration between Cyclone 5 and Intel Agilex 5 devices is not possible because of the different architectures used in both families. In Cyclone 5, all transceiver blocks in PMA and PCS are clocked by serial or parallel clocks derived from the same clock source, which is either from the channel PLL or fractional PLL. The channel PLL or the FPLL feeds the clock dividers in each channel, which then outputs the serial or parallel clocks to clock the data path. In Intel Agilex 5, the architecture introduces system clocking, which differs from the transceiver clocking used in the Cyclone 5 device. Between the analog PMA and the digital hard IP blocks, there is a PMA interface block. All blocks between the PMA interface blocks and the FPGA core are digital blocks which include MAC, PCS, FEC, and core interface FIFO. In most cases, the system PLL clocks these digital blocks, and its own clock clocks the analog block. Agilex 5 supports TX bonding. Use the same reference clock for bonding configuration in Intel Agilex 5. Use the local reference clock for by2 and by4 configurations, with 4 channels within a transceiver bank, and use the regional reference clock for by6 and by8 configurations. Note that Agilex 5 device does not support RX bonding. Intel recommends creating Intel Agilex 5 PCIe interface IP from scratch, and not from your existing Cyclone 5 design. The PCIe hard IP application interface in the Cyclone 5 device is designed based on the Avalon ST protocol, while Intel Agilex 5 is designed based on the AXI 4-string protocol. Hence, you must redesign the user logic connected to the PCIe hard IP application interface based on the AXI 4-string protocol. Supports PCIe endpoint, root port, and TLP bypass mode up to Gen 4 data rate and by 8-lane configuration. Use the PCIe hard IP only. Pipe mode is not supported. Not required to reconfigure the transceiver. A system PLL IP is required to be connected to the PCIe hard IP to provide the FPGA fabric clock. Separate reference clock supports with independent spread. You can implement independent PCIe interface up to by 4-lane width in each transceiver bank and up to by 8-lane width in every 2 transceiver banks. Intel Agilex 5 devices have Ethernet hard and soft IPs with significant performance and feature enhancements. Hence, you cannot directly migrate existing Cyclone 5 Ethernet designs to Intel Agilex 5 devices. Hardened MAC supports 10G, 25G. PTP is supported in the MAC. The PCS supports IEEE 802.3 compliant clause 49 and 64B, 66B encoding and decoding. Firecode and Reed-Solomon forward error correction is supported. PMA rates of 17.16, 28.1 gigabits per second supported, and Ethernet rates of 10, 100 meg, 1, 2.5, 5, 10, and 25 gig are supported. Due to the difference in the devices supported in different Intel Quartus Prime editions, you cannot directly migrate Cyclone 5 designs from the Intel Quartus Prime Standard Edition software to Intel Quartus Prime Pro Edition software for the designs to target an Intel Agilex 5 device. Please refer to the free e-learning, Migrating to the Intel Quartus Prime Pro Edition software, that is available that goes over the steps of migrating an Intel Quartus Standard project to an Intel Quartus Pro project. Intel provides multiple avenues in which to learn about Intel FPGA products. There is the Intel FPGA YouTube channel, which contains 5 minutes quick videos along with longer, more in-depth training videos. There is the Intel FPGA training website, where you can access e-learning courses made up of narrated slides presented in an interactive player, some courses with labs and demos. Lastly, you can also enroll in a live, instructor-led course presented either in person, at an office local to you, or virtually over the web. All instructor-led courses have hands-on labs exercises to practice the concepts you learn. If you need more assistance, Intel FPGA provides many self-help resources for you to access. For example, there are web pages called landing pages dedicated to specific FPGA technology like and high-speed interfaces. You can also view and post questions to the community forum, which is monitored by skilled Intel FPGA applications engineers. The Intel FPGA training team is always looking to improve our material and welcome any feedback you may have. Please email fpgatraining@intel.com with any of your thoughts or comments. This concludes the training. Thank you and have a good day.